see if you can evaluate this integral right over here. So I'm assuming you've had a go at it, so let's work through this together. So you probably realize that some of the traditional techniques that we've already had in our toolkits don't seem to be directly applicable, u substitution and others. And the key here to realize is we have a rational expression here where the numerator has the same degree or higher than the denominator. In this case, the numerator and the denominator have the same degree. And whenever you see something like that, it's probably a good idea to divide the denominator into the numerator. That's what this rational expression could be interpreted as, x minus 5 divided by negative 2x plus 2. So let's do a little bit of algebraic long division to actually divide negative 2x plus 2 into x minus 5 to see if we can rewrite this in a way that where we can evaluate the integral. So let's do that. We're going to take x minus 5, so x minus 5, and divide negative 2x plus 2 into that. So negative 2x plus 2. So look at the highest degree terms. How many times does negative 2x go into x? Well, it's going to go negative 1/2 times. Negative 1/2 times 2 is negative 1. Negative 1/2 times negative 2x is just going to be positive x, just like that. And now we want to subtract this yellow expression from this blue expression. And so let me just take the negative of this and then add. So I'm just going to take the negative of it and add. And so we are left with negative 5 plus 1 is negative 4. So you could say negative 2x plus 2 goes into x minus 5 negative 1/2 times with negative 4 left over. So we can rewrite this integral, our original integral, as, we can rewrite it as negative 1/2 minus 4 over negative 2x plus 2 dx. And let's see, it looks like we can simplify this expression a little bit more. The numerator and the denominator, they're both divisible by 2. All of these terms are divisible by 2. Actually, we have all these negatives. That always unnecessarily complicates things. So let's actually divide the numerator and the denominator by negative 2. So what are we going to have then? So if we divide the numerator by negative 2, if we view this as negative 4, this is going to become positive 2. Then this, if we divide negative 2x by negative 2, that's just going to become x. And then 2 divided by negative 2 is going to be minus 1. So our original integral, and once again, this is just algebra. Everything we've done so far is algebra. We've just rewritten it using a little bit of algebraic long division. Our original integral has simplified to negative 1/2. And some might argue it's not simplified, but it's actually much more useful for finding the integral. Negative 1/2 plus 2 over x minus 1 dx. Now, how do we evaluate this? Well, the antiderivative of negative 1/2 is pretty straightforward. That's just going to be negative 1/2 x. Negative 1/2 x. But what's the antiderivative of 2 over x minus 1? And you might be able to do this in your head. The derivative of x minus 1 is just 1. So you could say that the derivative is sitting there. And so we can essentially do u substitution in our heads and say, okay, let's just take the antiderivative, I guess you could say with respect to x minus 1, which would be the natural log of the absolute value of x minus 1. If all of that sounds really confusing, I'll actually do the u substitution. So if I were just trying to evaluate the integral 2 over x minus 1 dx, I could see, okay, the derivative of x minus 1 is just 1. So I could say u is equal to x minus 1, and then du is going to be equal to dx. And so this is going to be, we can rewrite in terms of u as 2, I'll just take the constant out, 2 times the integral of 1 over u du, which we know is 2 times the natural log of the absolute value of u plus c. And in this case, we know that u is x minus 1. So this is equal to 2 times the natural log of x minus 1 plus c. And so that's what we're going to have right over here. So plus 2 times the natural log of the absolute value of x minus 1 plus c. And the plus c doesn't just come from this one. This, in general, when we're taking the integral of the whole thing, could be some constant, because obviously if we go the other way, we take the derivative, the constant will go away. So let me just put the plus c right over there, and we are done.